is operations on complex numbers. Operations on complex numbers. Just like we did in our junior classes, we learned 1, 2, 3, how to write it. My daughter is still struggling to write 1, 2, 3. And soon as she will learn how to add them, subtract them, multiply them. In the same way, now you know what is a complex number, how do you write a complex number. Now we learn how to operate on them. So the first thing that we learn is comparison of complex numbers. So when two complex numbers are compared, that means one is equated to the other. So let's say your complex number was a1 plus ib1 and you are equating it to a2 plus ib2. Remember, we compare real with real and imaginary with imaginary. So when you compare two complex number, basically you are comparing two ordered pairs. Remember, we did a chapter called relations. Before relations, we talked about Cartesian product, right? Hindi, we call it as Kartiye Gunan. In Cartesian product, we learned how to deal with ordered pairs. So when we equate one ordered pair to the other, we normally compare the first element to the first element, second element to the second element. Okay. However, you will be happy to know that there is no inequality operations between complex numbers. Such operations are not, you can say, it doesn't make sense on complex numbers. Does it make sense to say one vector is greater than the other? Does it make sense to say one coordinate is greater than the other? No, right? So in the same way, it doesn't make sense to say one complex number is greater than the other. However, we can say one modulus of a complex number is greater than the modulus of the other complex number. Modulus comparison can be done. Argument comparison can be done because they're all real numbers, right? But a two-dimensional comparison is not possible. Are you getting my point? So there is nothing like Z1 greater than Z2 or Z1 less than Z2. Okay. Equality means real part is equal to the real, imaginary part is equal to the imaginary. Okay. One simple question somebody can ask you. Let's take some question. Why not take a question on this also? I'm sure I have few questions. Not very sure. I cannot promise you. This is what I do not like, searching for questions. Yeah, I think we can take this one. This probably would be one of your questions in your R.D. Sharma book or your NCERT for that matter. If x plus iy to the power 1/3 is a plus ib, then x by a plus y by b is equal to which of the following options? Would you like me to run a poll for this, or would you like me to solve it? Would you like to try? Okay, Charan wants to try. Good, Charan. That's the spirit. Chalo, chalo. Let's do it. Sir, it is like your questions are the ammo when you have fully loaded. Yeah. Yeah, normally I don't like to waste my and your time writing the question down. So I normally handpick them in the beginning of the class. Okay. Especially the one which helps me to convey all the concepts properly. Okay, 4 of you have responded and all of you have gone with the same options. So seems to be correct. Can we wrap this up in another 30 seconds? Not a difficult question. As I already discussed with you, all your operations of identity, or so as to say, all your binomial theorem concepts will equally work on complex numbers as well. So hint is cube both the sides. This is the hint which you can use. Okay, 5, 4, 3, 2, 1, go. Good, good, good. Everybody has voted on the same option. Awesome. Anyways, so let me share the result with you. 14 people have voted. All of them have gone with B. So high chance that B is correct. Okay. So let's cube the right hand side. So this will be A cube, 3A square IB, 3A IB square plus IB cube. So A cube. Now what I'll do is, first I normally take all the real terms together. So I think this will be a real term, this will be a real term, which will be minus 3AB square. Okay. And I take the imaginary terms together. So one with yellow tick mark will be having i's in them. Correct me if I have missed out anything. Now, as we have already discussed, real part will be equated to the real. And imaginary part would be equated to the imaginary. Okay. Now, what does the question demand from us? The question demands from us x by a plus y by b, right? So from here, I can say x by a is a square minus 3b square. And y by b from here will be 3a square minus b square. Let's add them. Let's add them, and our required expression would become 4 times a square minus b square. Janta, absolutely correct. Option number B is the right option. Cool, good. So we'll do one more. No, I think it's fine, sufficient, good enough. Okay. So this is the comparison of complex numbers. Now we'll take a break. So addition is the next operation that we are going to talk about, addition of complex numbers. Now in school, addition is basically explained in a very simple process that if let's say Z1 is A1 plus IB1, Z2 is A2 plus IB2. So when you add these two complex numbers, all you need to do is add the real with the real. Okay. Basically mangoes will get added to mangoes and bananas will get added to bananas, right? So the real part of each complex numbers will get added together and the imaginary part of the complex numbers will be added together along with their unit I. Okay. Now, what is missing from your NCRT or the way it is taught in school is how do we normally perceive this operation? And where is your Z1 plus Z2 located on the Argand plane, given that we know where is Z1 and Z2 located? Let us try to understand that. So let's say my Z1 and Z2 are located as follows on the Argand plane. So let's say this is our Argand plane, a real Z, imaginary Z. Okay. Let's say this is your position of Z1. This is your position of Z2. Okay. So as a point, it is A1 comma B1. And as a point, this is A2 comma B2. Let me name it A and B. Okay. Now, where is Z1 plus Z2 located? That is more important for us to understand because later on we'll get a lot of questions where we need to know the geometry of the problem in order to solve it quickly. So where is A1 plus A2 comma B1 plus B2 located? Our basically purpose is to locate this guy. Okay. Now you'll say, sir, if I know A1, A2, if I know B1, B2, I will locate it. What is the big thing in that? Okay. Absolutely. If you know your A and B, A1, B1, A2, B2, you can locate it on the Argand page. But let's say even if your A1, B1 and A2, B2 is not exactly known, we should know where is A1 plus A2, comma B1 plus B2 located. Now here is the claim that I'm going to make over here. If you complete a parallelogram using these two as the adjacent sides. So let me complete a parallelogram. Okay. Using these two as the adjacent sides. This vertex that you see, this is basically your Z1 plus Z2 vertex. Okay. Or for that matter, this is your, I should not write it in bracket. This is your A1 plus A2, comma B1 plus B2. Right? Why it is very easy to prove it? See, if you make a parallelogram, we know that in a parallelogram, the diagonals bisect each other, correct? So let's say I call this as M, okay? So M is the midpoint of not only AB, but also it is the midpoint of, let's say I call this as OC for the time being. Let's say I call this point as C for the time being. So because of my construction, M is midpoint of AB as well as OC, correct? By the virtue of the fact that M is the midpoint of AB, we can say it is A1 plus A2 by 2, comma B1 plus B2 by 2. Correct? Now, let us say for the time being, I take this as C comma D. Let's say I take it as C comma D. So can I say M will also have C plus 0 or 0 plus C by 2, comma 0 plus D by 2. Now, since both the points represent the same point, I can easily compare the X coordinate with the X coordinate of the other, which will clearly give me C as A1 plus A2. And I can compare the Y coordinate with the Y coordinate of the other. That will give me D as B1 plus B2. And hence my assumption that this point C will be A1 plus A2, comma B1 plus B2 is absolutely spot on. It's absolutely correct. And this point will represent your sum of the complex numbers Z1 and Z2. Right? This basically resembles your parallelogram law of addition. It resembles your parallelogram law of addition. And why won't it? It should be actually, because complex numbers are actually position vectors. So they will definitely resemble your vector method of adding the complex numbers. Is this fine? Any questions here? Any questions, any concerns? All right. Couple of things I would like you to understand here, apart from the fact that you know how it is geometrically represented. If I connect O to C, the length of OC will be called as mod of Z1 plus Z2. Now, it's needless to say, because mod of any complex number is nothing but it is the length of the line connecting origin to that point, or length of the line segment of the line connecting origin to that point, isn't it? Okay, so this is your mod Z1 plus Z2, and this angle that you see here, this angle would be your argument of Z1 plus Z2. Right? I'm not teaching you anything new. Z1 plus Z2 is also a complex number. So just like any other complex number, it should have a modulus and it should have an argument. Correct? And I'm just following the modulus and the argument definition. But what is important here, or what is the important takeaway from here is that, number one, Z1 plus Z2 modulus will always be less than modulus of Z1 plus modulus of Z2. Why? Why? Can somebody tell me why? Why it should be less than equal to? Why not equal to? Absolutely, Aditya. See, as you can all see that since it is a parallelogram, this length is mod Z1. Oh, I'm sorry, mod Z2, my bad. This length OB is mod Z2. And this length is same as the length of OA. So this is mod Z1. Now, all of you, please focus in the triangle OBC, right? In any triangle, it is known that the third side is always less than the sum of the other two sides. Okay. So in this triangle, let me write it down. In this triangle, we can say that OC is less than OB plus BC. Now, there can be equality also provided the triangle becomes flat. Okay, provided the triangle becomes flat, okay, there will be equality also, and hence I have written equal to sign. Okay, so here is a point that you should all note. Equality holds when this triangle is flat. Now, this triangle is flat can be written in a very technical term as saying argument Z1 is equal to argument Z2. Now, this itself can be an important question framed in a competitive exam. So please make a note of it. So they may ask you this question that mod Z1 plus Z2 is equal to mod Z1 plus mod Z2. Then which of the following option is correct? And in one of the options, they will say argument Z1 is equal to argument Z2. So you have to mark that option. Is this fine? Please make a note of it. Another thing that you would all see over here is that, any questions? Can you please repeat the last point Shashwat is asking? See, what I said was, in your exam, competitive exam, they can give you that if mod Z1 plus Z2, okay, let me just frame a question here. So this could be a possible question. If mod Z1 plus Z2 is mod Z1 plus mod Z2, then which of the following option is correct? Option A, they will say argument Z1 plus argument Z2 is 0. Option B, argument Z1 plus argument Z2 is equal to pi. Option C, argument Z1 is equal to argument Z2. Option D, argument Z1 plus argument Z2 is equal to pi by 2. Such kind of questions can come. So your answer will be obviously option number C. Is this fine? Shashwat, now it's clear what I wanted to say? Okay. All right. So yeah, we are not done with it. We have one more important finding that comes out from here. And again, that is based on your triangle inequality, that the third side will always be greater than the difference of the length of the other two sides. Okay, so the outside mod symbol represents the difference. And this is basically the difference of the length of OB and O, and you can say OB and BC. Okay, so in a triangle, let me write it down, because in a triangle OBC, the third side will always be greater than the difference of the other two sides. Okay, because both these properties come from the triangle properties, they are famously called the triangle inequalities. So they are called the triangle inequalities. Is this fine? Any questions? Any question? Okay. Now I would like you to solve a simple question on this. Not a very simple question, but yes, a good question. Let's take this question. The question is, if mod of z plus 1 by z is equal to 2, find the maximum and minimum value of mod z. Find the maximum and the minimum value of mod z. Let's see who is able to crack this question. Any idea how to proceed? Anybody? Okay, I think this is a slightly difficult question for you to solve at this point of time. Okay, fine. Take your time. Pranav and Anurag. Okay, Pranav. Okay, Aditya. So the only complex number which has got its modulus as 0 is 0 itself. So you can say z can be 0. I don't think so. That is right. Acha, okay, let me solve this because it requires a bit of deeper understanding of the triangle inequalities. See, if you just recall your triangle inequalities that we had done, we have learned the second one, that mod z1 plus z2 is always greater than equal to the difference of the other two sides, right? Correct? Okay. Let us consider z1 to be z and z2 to be 1 by z. So if I apply the same fundamental over here, this is what I will end up getting. Okay. Now, it's too early for you to figure this out. This is basically based on one of the properties that you will learn in modulus. That one of the properties you learn in division, that if you have one complex number divided by the other and you're taking the modulus of the whole thing, you can actually write it separately as modulus 1 by modulus z. And modulus 1 is actually 1 only, right? Okay. So you can write it like this. Okay. Now this value is already given to us as 2. Yes or no? Correct. Now, when I say, now this outside mod is your normal mod that you have seen in your real number also. So if somebody says mod of a quantity, let's say y, is greater than 2, what does it mean? What does it mean? It means y lies between minus 2 to 2, correct? Yes or no? Correct. So can I say this is as good as saying mod z minus 1 by z lies between minus 2 to 2? Correct? Is that fine? Okay, now this is equivalent to saying two inequalities, one being mod z minus 1 by z is less than equal to 2, and simultaneously mod z minus 1 by z is greater than equal to minus 2. Correct? Now let us solve this first. So if you simplify this, this is what you are going to see. Am I right? Please note, I took the LCM of mod z, took the mod z to the right side. Remember, it's a positive term, so it will not change my inequality, and brought it to the other side. This you can write it as minus 2. 2 you can write it as root 2 square. Okay. So basically I have written this minus root 2 square less than equal to 0. So this we can factorize as mod z minus 1 minus root 2 and mod z minus 1 plus root 2 less than equal to 0. Right? Now, whenever a quantity, whenever an equation like this comes to us, okay, it reminds me of this x minus alpha, x minus beta less than equal to 0. Right? So if you remember your inequality chapter, this was satisfied by those values of x which lied between alpha and beta, right? Okay, I hope everybody remembers this. If you don't remember this, means you're not revising your previous chapters, you're not solving, you're not practicing questions. Okay, so in light of this, I can say that mod z should lie between root 2 minus 1 and root 2 plus 1. Correct? And there you go, we are done. If mod z is greater than equal to some quantity, that means its minimum value is root 2 minus 1. And if it is less than equal to some quantity, it means its maximum value is root 2 plus 1. There you go. This is your answer. Okay. You don't even have to solve the second one. Okay. This is one of the favorite questions that competitive, JEE and other competitive exams, they ask. Is this clear? Is this clear? Does it make sense? I'll give you some time for you to realize this. Take some time. Oh, 1 second, 1 second. Yes. Yeah, sorry. Yeah, I think one small thing that I would like to add over here. This is giving you a 1 minus root 2. Yeah. Okay. Oh, yes. Absolutely correct. Absolutely correct, Aditya. So this is always true. So at least this gives me mod z is less than root 2 plus 1. Yeah, thanks for correcting me. So mod z maximum value is root 2 plus 1. Okay. Now, unfortunately, we have to solve the second one also. Okay, so this also needs to be solved. Okay, so when you solve this, I'll just quickly write down the expression for this. This is what you will end up seeing. Correct me if I'm wrong. Okay, so this is okay, plus 1 minus root 2. Yeah, so this is of the type x minus alpha, x minus beta is greater than equal to 0. Let's say if alpha is less than beta, then the solution to this is x should be less than equal to alpha, or x should be greater than equal to beta. Okay, I hope everybody remembers this fact. Correct? Okay, please recall this. We had done this in our linear inequations chapter. So here I can say mod z is less than the lesser of the two. The lesser of the two will be minus 1 minus root 2, which is not possible. Or mod z is greater than equal to root 2 minus 1. Now, if this is the possibility, it automatically implies that the minimum value is going to be root 2 minus 1. Okay, so sorry for this confusion there, because it was giving you -1 minus √2 because it's a negative quantity. Negative quantity, it's always true. This is always true. Okay, so from here we end up getting the exact thing. The minimum value is going to be this. Is it fine? Okay, now just to save your time in the examination hall, because I know most of you would be feeling that, oh, I need to do so much thing to figure out the answer to this question. Yes, ideally speaking, you have to do this. But let's say if you want a shortcut, I have a shortcut for you. You may note down. In fact, I can give you a formula which will save a lot of time for you. The formula that I would like to share with you, which is based on the same approach. If you have been given that mod of z plus minus b by z is equal to a, okay, and they ask you the greatest value and the least value of mod z, then the answer is the greatest value is given by a plus under root of a square plus 4 mod b by 2, and the least value is minus a plus under root a square plus 4 mod b by 2. Okay, please note this down. This will save a lot of your time. However, if you want to know what is the genesis of this result, the genesis of this result is exactly what I did in front of you. You just have to write it in terms of a and b, and you'll be finding these two results. So please make a note of it. So as per my given question, a was 2 and b was 1, I guess. Okay, so your greatest value would be 2 plus under root of a square, that is 4, okay, plus 4 by 2, which is actually 2 plus 2 root 2 by 2, which is actually root 2 plus 1. Root 2 plus 1. Okay, and your minimum value would be minus 2 plus 2 root 2 by 2, which is root 2 minus 1. That's what we got here, root 2 minus 1. Okay, so this really saves a lot of your time if you're doing it in the competitive level exam. So please make a note. Is it fine? Any questions, any concerns? Let me check if I can find a few more questions. I think all easy questions are there on this as of now. Ayyo Rama Krishna. Okay, I think we can take this question. I will not even run a poll for this because it is too easy. It is touch and go. I want your answer immediately on the chat box. Which option is correct? Fast. A, B, C, D. Which option is correct? Absolutely, absolutely. Everybody spot on. Option number A. Yes. Touch and go. Okay. Next. Next. On a similar line. Can you hear Pranav? Can you hear me? Hello, Pranav. Absolutely, very good. B is correct. Absolutely. Okay. So these are some simple questions that can be framed. Of course, we'll come to more complicated ones in some time. Let us now talk about the operation of subtraction. Normally, we study addition and subtraction together because the concepts are more or less linked. Okay. So let's say if you have a complex number a1 plus ib1 and you have another complex number a2 plus ib2. When you do z1 minus z2, basically you subtract the real with the real and you subtract imaginary with the imaginary. Okay. And more than this, this is an operation which, I mean, it's okay to understand how it works, but more importantly, we need to understand the meaning of what is happening when you are subtracting one complex number from the other. See, first let me write this operation like this. It is basically z1 plus negative z2. So when you're subtracting z1 minus z2, you're adding z1 with negative z2, right? So if I represent them, let's say I have this as my z1. Okay. And if I represent this as z2. Okay. When I say z1 minus z2, it is as good as adding z1 with negative z2. So if this is z2, can I say negative z2 will be here? Okay. Negative z2 means you are exactly taking the mirror image of that point about the origin, right? Both x and y, or we can say both a and b coordinates of that ordered pair will be reversing their signs. Correct. Now you follow your parallelogram law of addition. So this and this, treating them as the adjacent sides. If you complete a parallelogram, I'm just assuming that my parallelogram comes out to be good. Yeah, good, decent one. Then this point that you see here, that would be your z1 minus z2. Okay, you can figure it out in the same way as we figured out the location of z1 plus z2. So this point is your z1 minus z2, right? Now many students say, sir, you don't have to draw a parallelogram like that. You could have got the complex number. Okay, anyways, first of all, you note this down. Then I will discuss more about it. Okay, so if this point is a1 comma b1, this point is a2 comma b2, then this point is a1 minus a2 comma b1 minus b2. Okay. Okay. Now from this diagram, what is the magnitude of z1 minus z2? So you will say the magnitude of z1 minus z2 is the length of this line. Correct. So this line is mod z1 minus z2. Correct. Right. So let's see, I call this as A point, B point, let's say C point. Okay. So length OC is your magnitude of z1 minus z2. What is argument of z1 minus z2? So you'll say this angle theta. Okay. So this angle theta is your argument of z1 minus z2. Correct. No doubt about this. Now, when I say this to students, they suggest me several methods. They say, sir, actually you need not find minus z2, and you need not make this parallelogram. You can do everything over here only. How? So let's say I complete a parallelogram like this. Okay, just correct me if I'm making sense over here. Yeah. And they say, sir, this length that you see, this will be same as this length. So that means they are saying AB will be same as OC. Do you agree with it? Yes, absolutely. That logical, that conclusion is absolutely valid. AB length and OC length will be exactly equal to each other. So you can say that mod Z1 minus Z2 basically represents the distance between Z1 point and Z2 point. This is very, very important. Please note this down. Super important concept. Super important. Very important concept. Mod Z1 minus Z2 represents the distance between the 2 points A1, B1, comma, A2, B2. There's another way to validate this. If I say Z1 minus Z2, we all know it's A1 minus A2 plus I B1 minus B2, right? So if somebody wants to do this, as per the definition of modulus, he has to do this. Correct? And when you look at it, you realize, oh, this is the distance formula. This is the distance formula that we had studied in our coordinate geometry. Correct? So that's why instead of finding this C point, you could actually figure out at least the modulus by connecting A and B. Sorry, connecting A and B and knowing the length of that particular line segment. Okay. Now, many people say, sir, do you have any way to figure out this theta? Yes, there is a way to figure out that theta. All of you, please listen to this very carefully. When I ask students that from this blue parallelogram, can you figure out what is the argument of Z1 minus Z2? Then I get to hear two answers. Some people will say this angle. Okay. Some people will say this angle. Now you definitely know that this is your answer. This is not your answer, right? But this is for those people who want to conclude the argument of Z1 minus Z2 from this blue parallelogram. Okay. Of course, if you make the yellow parallelogram, everything will be very clear. Everything will be crystal clear to you. But if you want to make a judgment on what is the argument of Z1 minus Z2 based on the blue parallelogram, then this is one small trick that I would like to share with you. Assume that there is a vector starting from Z2 to Z1. Assume that there is a vector starting from Z2 to Z1, not from Z1 to Z2. Hear this out. Assume that there is a vector from Z2 to Z1. That means initial point is Z2, terminal point is Z1. Okay, so basically I put a direction like this. I hope you can see that direction on your screen. Correct. Now, let's say your direction of real Z axis is like this. Okay. Now I want all of you to tell me, how do you find the angle between two vectors? So if one vector is like this, other vector is like this, how do you find the angle between two vectors? Can somebody unmute himself or herself and tell me? Or at least write down on the chat box. I'm sure you have done this in physics. Dheeraj sir would have taught you this. No, I don't want any rule. I want which angle. So what do you do to find the angle? So you will say, sir, I will make it co-initial. Okay. When you make that co-initial, the shortest angle between them is basically the angle. Correct. This is what you do, Aditya. Correct. So in the same way, if you see what is the angle between BA vector and your positive real Z axis, you can say only this will be your angle and this will be your argument of Z1 minus Z2. So you don't have to make a yellow parallelogram to decide that. You can decide it from the blue parallelogram. So blue parallelogram is a one-stop solution for you to find your mod Z1 minus Z2, which is your other diagonal length. And if you create a vector out of it, okay, and find the angle between that vector and the positive real Z axis, that will be your argument of Z1 minus Z2. Remember, if I say argument of Z2 minus Z1, then there's a change. Argument of Z2 minus Z1, this will be different. In this case, your vector will come from Z1 to Z2. So your vector will come like this. Okay. And in that case, this angle will be the angle between, or this angle will be your argument of Z2 minus Z1. Guys, please be very, very careful, because a small mistake here can lead to faulty results. Why do we use a positive y-axis? Do we use the positive y-axis? No, no, no. We don't use the positive. Always positive x-axis. Argument is always taken from your positive. Remember, when I was teaching you trigonometry also, I told you every angle has its initial side on the positive x-axis direction, right? Only the terminal sides keep on moving. Okay, so angle is always considered from the positive x-axis, positive real z-axis in this case. I should not use x-axis word. Okay, is this fine? Okay, now here also we have some inequalities. By the way, let me name it as phi, because I can use it over here. Okay, so please note this down. This is very, very important. So some triangle inequalities, which is true even for a case of subtraction. Number one, mod Z1 minus Z2 will always be less than equal to mod Z1 plus mod Z2. Now it's very obvious. If you look at this triangle, triangle OAB, this length is mod Z1 minus Z2. This length is mod Z1. This length is mod Z2. You always know that in any triangle, the sum of the two sides is always more than the third. In this case, you can put equal to also. And now that would be my next question to all of you. When do you think the equality holds? When do you think the equality holds? The equality holds when? Who will finish that up? Talk in terms of argument, etc. Okay. Don't say, sir, the angle becomes, it collapses or whatever. I don't want that geometrical meaning. I want the technical word to be used. When do you think mod Z1 minus Z2 will become equal to mod Z1 plus mod Z2? Think and answer. Think and answer. No. No, Aditya. Absolutely, Madhav has got it. When their arguments are pi apart. Take a salute, Madhav. Hats off. Very good. See, Madhav has very beautifully cracked this problem. See, read this. In your mind, if you read this, it is basically the distance between Z1 and Z2. Am I right? Correct? It's there on your screen. Here, see here. See here. It's distance between Z1 and Z2. Now ask yourself, when is the distance between Z1 and Z2 same as the sum of the distance of Z1 from the origin and the sum of the distance of Z2 from the origin? It can only happen when their positions are on the opposite side of the origin. So if Z1 is here and Z2 is here, then only I can say this distance, which is your mod Z1 minus Z2 distance, will be same as this distance, which is mod Z1, plus this distance, which is mod Z2. Okay, so the technical term that you have to use here is the difference of the arguments of these two complex numbers should be pi. Please note this down. This has come as a direct question in many competitive exams. This symbol that you see is a difference symbol. Difference means you don't know which is more. You don't know whether Z1 argument is more or Z2 argument is more. That's why I wrote a difference. Okay. Many books will write it as this: argument Z1 minus argument Z2 mod is equal to pi. This is another way to say it. Or many books will write argument Z1 minus argument Z2 is plus minus pi. All of them mean the same thing. It's just about your understanding of the concept. Okay. No. Z2 itself has an argument which is pi apart from the argument of Z1. Z2 itself is in the opposite side of the origin. It's not about minus Z2. Minus Z2, if I take minus Z2, will come over here. That's another thing that I'll ask. I didn't get your question, Anurag. Won't it be 0 after we flip it? Where have I flipped it? Why do I need to flip it? See, understand this again. What I'm trying to say is that if Z1 and Z2 are located in this fashion, then this equality will hold true. That means mod Z1 minus Z2 will be equal to mod Z1 plus mod Z2. Why? I'm trying to validate my this thing, concept theory over here. See, if Z1 and Z2 is located in this way, we can say that the distance between Z1 and Z2, which is mod Z1 minus Z2, will match with the sum of its distances or sum of their respective distances from the origin. So this position is absolutely justified. That is what I'm trying to explain. You have a perception that Z2 is always in the first quadrant. So if something comes in the third quadrant, it should be minus Z2. I would like to change that. Z2 can be anywhere in the 4 quadrants. Right, Anurag? You have a feeling that Z2 is always in the Z1 and Z2 are always in the first quadrant. No, need not be. I can take Z1, Z2 anywhere I want. Okay. Okay, Aditya has a question. Okay, sir, can we say that this will have a max value? Yeah. See, Z1 minus Z2, see, it's not a max value. Z1 and Z2, distance between them is always connected by a straight line. It's not that any one of them is moving around that you can talk about max or min value. It's a fixed distance. So it's like asking somebody, what is the max distance between 2 points? How will you answer that, Aditya? Mod Z1 minus Z2 is what? It's the distance between Z1 and Z2. So what is the logic of max and min over here? I'm not very sure. Okay. All right. Second inequality that, my space has gone over here. Okay, I'll write it over here. Second inequality, and I think you would easily guess it, that mod Z1 minus Z2 will always be greater than the difference between the two complex number. Again, from the very same triangle, that is triangle OAB, I can say the third side length is always more than the difference of the two sides. Now, I have a question again. Equality holds when? When will it be equal? When will mod Z1 minus Z2 be equal to mod Z1 minus mod Z2? This thing. I'm sure you should answer this. You already have seen the previous argument. When one of them is 0, one of them is 0 is a special case of a broader argument. Let's say if it is not 0, then can't the equality hold true? That's my question. Equal to 0 is obviously there, Madhav, but that's a special case of a broader case. I want that broader case. And I'm sure you can answer it, Madhav. When does the distance between Z1 and Z2 equal to the difference of the distances from their origin? Yes. Can you say that in a more better way? When argument is equal. Yes. This is what I wanted to hear. Absolutely. Okay. Again, it's very justified. See, what I'm trying to say is that If your Z1 and Z2, let's say Z1 is located here and Z2 is located here. Okay. So what is this trying to say? Or what question this poses at you? When do you think this distance is equal to this distance minus this distance? Only under this condition only, which I've shown you on the screen, isn't it? So mod Z1 minus Z2 will be equal to mod Z1 minus mod Z2 only when they lie on the same side of the origin along the same angle. That means their arguments are equal. Are you getting my point? So this can come as a direct question to you in the competitive exams. Are you getting my point? Is it clear? Is this clear? Everybody, is it clear? Okay. Based on this, I would like you to tell me this. If mod Z1 plus Z2 is equal to mod Z1 minus Z2, okay, then what can you comment about the difference of argument of Z1 and Z2? Option A, will it be 0? Option B, will it be pi? Option C, will it be pi by 2? Option D, none of the above. Think and answer. Think carefully and answer. Very good, Madhav. Nice. It's written here, no, Anurag. If mod Z1 plus Z2 is equal to mod Z1 minus Z2, then the difference of the argument of Z1 and Z2 can be which of the following? Good, 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 good. I'm getting two types of answers, B and C, B and C, B and C. Should I run a poll? Better to run a poll. Okay, I want to see how many of you are voting for which option. Right, Madhav, I can see that nobody has voted for A and D. Okay. All right, so let's conclude the poll. Given that C is leading now, sir, you are influencing the vote. Okay, given that C is leading, let's see what is the answer. Okay, guys, on a serious note, let's close the poll in another 5 seconds. 5, 4, 3, 2, 1, go. So my statement influenced. This is called conditional probability. Anyways, you study about it in class 12th. Most of you have voted for C. Now answer is C. Actually, it's correct. See, guys, this can be very, very easily done if you understand the geometrical interpretation of what is the meaning of this and what is the meaning of this. It means that there is a triangle. Oh, sorry. It means that there is a parallelogram. I'm so sorry. Not a triangle, a parallelogram whose diagonals are equal. Oh, sorry. So there is a parallelogram whose diagonals are equal. Right? So let's say this is my Z1, this is my Z2, and I make a parallelogram which happens to be a rectangle. Only under this situation the diagonals can be equal. Am I right? Isn't it? So this length, which is mod z1 plus z2, will match with this length, which is mod z1 minus z2, only when the parallelogram is a rectangle. Yes or no? Do you agree with me on that or not? When can the two diagonals of a parallelogram be same? Only when there's a rectangle. And if there is a rectangle, you can clearly see that if this is theta, let's say argument of z2 is theta, then argument of z1 should be 90 degree plus theta. In other words, the difference of the argument, now I'm not trying to claim that z1 is above and z2 is below. It can be either way around. Okay, it depends upon, okay, that's why difference I wrote. So it has to be 90 degree. So option number C has to be correct. Okay, so this brings me to your geometrical understanding of mod and the argument, which is very important. So I would like to take some questions with you. Let's take this question. If mod z plus 4 is less than equal to 3, okay, find maximum value and minimum value of number 1 mod z, number 2 argument z. Let's see whether you are able to tackle this. If mod z plus 4 is less than equal to 3, find the maximum value of mod z and minimum value of mod z, and same with argument also. Now, if you have understood the geometrical meaning of whatever we discussed so far, you'll be able to solve this question, at least the first part, within 30 seconds. Let's not do the second part as of now because I'll give you a different question. Let's do the first part only. For second part, I'll change the question slightly. Anybody? Okay. So this problem is the genesis of your locus understanding, because everything will evolve from the concept of your understanding of modulus and your understanding of argument operations. So if you look at this, okay, I don't know what picture it creates in your mind about z. So z is some complex number, I don't know where it is, but it always satisfies this condition that mod z plus 4 is less than equal to 3. How do you see this? That is more important. Now, I see this operation as if it says this to me. That is, z is a complex number such that the distance between z and the point minus 4 comma 0 is always less than equal to 3. Does it ring a bell in your mind? If still not, then basically it says if you consider a circle whose center is at -4, then your z lies, and radius is 3, then your z lies within the circle. If this image is getting built in your mind, then think you are on the right track. Absolutely, Aditya, I think that image started building up for him. See, understand this. Z is something which I don't know where it is, but it is satisfying this inequality. Correct? This inequality, I'm reading it like this, right? Now I have come from the concept of mod Z1 minus Z2. Mod Z1 minus Z2 gives you the distance between Z1 and Z2, right? So in the same way, the distance between this guy and -4 is the center over here. So Z is somewhere. I mean, let's say it is here. Okay. This distance, it is saying it is always less than equal to 3. That means if you take a circle of radius 3 with the radius, with the center as -4, 0, you are within or on the circle. Are you getting my point? This is that question is trying to convey you indirectly. Now, what is the question asking you? What is the maximum value of any point on this from the origin? This means what is the distance of z from the origin, max value. So max value will be when you're looking at, when you're looking at this point, no, this point will be at max distance from the origin. Am I right? So this answer will be 7. So the answer for this is 7. And the min distance will be when you're looking at this point, and this answer will be 1. So min distance will be 1. Absolutely, Anurag. Absolutely. So that's why I said, if you're able to perceive it as an image in your mind, you'll be able to solve this within 30 seconds. There's nothing, difficult here. Are you getting my point? Okay. Let's say I want to make this question slightly more complicated, and I will introduce, the same question, but with a slight change in the statement. If mod of z plus 4 is equal to 3, okay, find maximum value of and minimum value of argument of z. How will you solve this? Okay, now I'm sure all of you know that it is again a circle, but this time not the inside region. This time you can only go on the periphery of the circle. Correct? So z can rotate only on the surface of the circle, not inside. Okay. Yes. Correct. Now tell me, which point do you think will make maximum angle with the positive real z axis, and which point will make minimum angle with the positive real z axis? So again, the answer will be the same. This point will make the maximum angle, which is pi, right? And the same point will make the minimum angle also with the pi, right? So minimum angle is basically something which is tending to minus pi. Maximum angle will be the one which is tending to pi. But let me frame this question in a slightly different way. Okay, let me do one thing. My intention was to ask you, okay, let's say I just erase this figure. Let's change my question. Question is now, there is a complex number which satisfies mod z minus 4 minus 4i is equal to 2. Find the maximum and the minimum value of the argument of z. How will you do this? Sorry, I had to change my question because, argument z. what is the maximum and the minimum value of the argument of Z? Pranav, can you see what I've written on the screen? Now I've changed the equation to be this. Now I'm asking you, what is the maximum and the minimum value? Absolutely, Madhav. So can you go ahead and complete it? You join again, Pranav. I'll stop my camera. Now can you see? Pranav, can you see now? Okay, do you all see this? So can I say when your Z is satisfying this condition, it is supposed to lie on this circle? Okay, Aditya, let's check. So can I say minimum value of the argument would be when you draw a tangent to the circle, just touching the tangent at this point? So this complex number, let's say I call it as Z1, this will have the minimum argument. This will be the minimum argument, right? And if you draw a tangent to this point, then this complex number Z2, this will have a maximum argument. Am I right? So the question setter is asking you, what is this and what is this? I'm sure you will be able to find that out. Let's do that question. Let's do that question. Okay, it's very easy to do it. If you make a right angle triangle over here, let all of you please pay attention. Okay, if I just connect a right angle triangle over here, okay, this is 2, okay, and this is 4 root 2, right? So what is this angle? Let me call this as phi angle. So what is phi angle? Phi angle is sine inverse of 2 by 4 root 2. That is actually sine inverse of 1 by 2 root 2. Correct? And this whole angle was 45 degrees. This whole angle was pi by 4. So can I say the minimum argument would be pi by 4 minus sine inverse of 1 by 2 root 2? Of course, these ugly figures will not be asked in the competitive exams. They'll probably give you a good number so that you end up getting a decent answer over here, right? And what will be the maximum value? What will be the maximum value? The same thing with a plus now. That's it. Okay. So you don't need rocket science to solve this. How did you get pi by 4? Anurag, if this is 4, this is 4. How much is this angle, Anurag? 45 degrees, no? 4, 4. How much is this angle, Anurag? 45 degrees, no? Okay. So if this is 45 degrees and this is sine inverse 1 by 2 root 2, just subtract it. Just subtract this angle. Let me show it with yellow. This angle from this angle, that will give you the minimum angle. Okay. Is this fine? Any questions, any concerns? Okay. So few things I would like to add over here. In fact, I would discuss this in another class also. Some important important loci. If somebody says mod z minus z1 is less than some number a, he basically wants you to draw a circle with center at z1, radius at a, and since it is less than, you will be inside the circle and the boundaries will be made with dotted lines. Okay. If somebody says mod z minus z1 is less than equal to a, you will be inside the circle having center at z1 and the outside circle will be solid line. Okay. Similarly, if somebody says z minus z1 is greater than a, make a circle with center at z1, radius as a, okay, and you will shade outside the circle with the circle being dotted. Okay. If somebody says mod z minus z1 is greater than equal to a, then think he is asking you for a region which is outside the circle of with center at z1 with circle being solid. Okay. So please remember these are very, very important things that we are going to use in our problem solving. It is just the tip of the iceberg that you have seen today. We'll go much more into details of this, especially when we are doing the geometry based problems on complex numbers. Okay. So we just could do the operations of addition and subtraction. Okay, so it's a very long chapter actually. Next class we'll talk about multiplication, division, square root, nth power, rotation theorem, conjugate, division. Okay, so many other things. Then we start going into a bit of coordinate geometry like equation of a complex line, complex slope of a line, equation of a circle in complex plane, all those things, Coni rotation formula, etc. Okay, 2 classes will be minimum required. So today we'll stop the session over here.